Now 14, in the alkane there is a given one alkane compounds right now, and he asked identify the 1 degree, 2 degree, 3 degree carbon atoms and give the number of hydrogen atoms bonded to each one these. Okay, now means first of all 9.8 NCRT example 9.14 CH3 say CH3 CH2 CH. Now give the answer. Numbering will start from left to right or right to left? Numbering left to right or right to left? This is the compounds right now. 1, 3, 4, 5. Here we get 3, 3, 3, 3, 5. And from this side 2, 3, 4. Means 2, 4, 4. Which one is the lowest locants? This one 3, 3, 5 or 2, 4, 4. Which one is the lowest locant? 2, 4, 4. So from this side it will start right now. This one is incorrect. Now this carbon is a primary, secondary, tertiary. Fast. This one is a primary. This carbon. This carbon. Primary. And this one tertiary, right now? Tertiary. Now this one? Secondary. This carbon? Quaternary, right now? 4 degree. 4 degree. Branch 1 degree, 1 degree. This one? Secondary. Primary. Everyone know right now? Now 15. What effect does the branching? 9.15. 9.15. Exercise first. 9.15. What effect does branching of an alkane chain has on its boiling point? What effect of branch in alkane? Decrement of boiling point. Why decrement of boiling point? Less surface area, right now. Means van der Waals force. First of all, it depends on molecular weight, right now. If molecular weight same, that time we check branch. Which having more branch, less surface area, right now. Less surface area means boiling point less, decrease. Means understood surface area, phenomena of surface area, sir. Okay. Now 16. Addition of HBr to propene yields 2-bromopropane while in the presence of benzoyl peroxide, means peroxide, right now. Benzoyl peroxide, this peroxides means what the alkene is given here? Propene 1, 2, 3. Prop 1 in. Propene yields 2-bromopropane. HBr. Br. And when HBr in the presence of benzoyl peroxide, that time it form 1-bromopropane, right now. 1-bromopropane. What happened here? Means it form 1-bromopropane, right now. In a initiation there is a free radical mechanism, right now. First step is what? Initiation. Second one is a what? Propagation. Third, terminations, right now. In a initiation, first this radical will form, right now. PHO means pH radical will form. pH radical will form, and this pH will come to the HBr, and here pH benzene will form, and Br radical will form, and this radical will attach on that carbon. This is the first step, formation of radical, initiation completed. Now bromine radical will attack on the HBr, right now. On compounds, this alkene, on this alkenes, right now. So Br will add on that carbon. Br, bromine radical will attack on that carbon, means to form the stable radicals, right now. Means if Br will attack here, means the radical will form on this carbon. 1 degree radical right now. How many alpha H are there? 1 alpha H. So this radical is stable. Now form on this radical. Bromine attack on this carbon. Radical on this carbon. How many alpha H are here? 2, 5 alpha H. It is bromine, no? One is bromine. 5 alpha H. Means it is a stable right now. Now hydrogen will come on attach on that carbon. Anti-Marconi Goc-ll right now. Now 17. Write down the product of ozonolysis of 1,2-dimethyl 1,2-dimethylbenzene right now. 1,2-dimethylbenzene, and also he mentioned support the Goc-ll structure. What the meaning of Goc-ll structure? Goc-ll resonating structure right now. He asked indirectly form the both resonating structures, okay, no? For ozonolysis. Means this one he gave the these compounds right now, these compounds, and he asked give the both Goc-ll structures of benzene. Bring first these compounds. Second one, if you replace the double bond, these compounds will form. Right. Now start the breaking compounds. From here, if you break these compounds, what is the form here? What's compounds? What compound is here? Means this one, right? Dimethyl glyoxal. From here you can get one is this compounds. This one is a two compounds right now. One is here, means one is here and one is here, right now. This compounds means CHO. One more compound is formed here. 2 moles of this one form and 1 mole of this one form right now. Means here is a methyl. Dimethyl. What the name of this compound? Goc-ll right now. Name of this compound is what? Goc-ll. And this compound name is dimethyl glyoxal. Means 2 mole of this one form and 1 mole of this one's form right now. And now here if you break this one, means 1 mole of this one form and 2 mole of methyl glyoxal will form right now. 1 mole of this one's and 2 mole of methyl glyoxal will form. How many products are formed here? 1 type, 2 type and 3 types right now. Total 3 types of product we can obtain here. We obtain here right now. Glyoxal, methyl glyoxal or dimethyl glyoxal from Goc-ll structure, from both resonating structures of benzene right now. Now 18. Arrange the benzene and hexane and ethane decreasing order of, means first what? Benzene and hexane and ethane in a acidic strength, acidic behavior right now. Benzene and hexane and ethane. Where is a more stable negative charge? Triple bonds. So this one will come first right now. Then benzene, because of sp2 atoms right now, will pull the electrons. Then this one's. So C, A, B. This is the order. Now that there is a one more questions right now, and also give the reason for this behavior. Also you can give write the reason. Sp will pull more electrons. That's why here negative charge is more stable. Here is a sp2 atoms right now. sp2 atoms who also pull the electrons. So that's why as compared to this one is more stable. And here is the plus I, he gave the electrons, he donate electrons, means electrons cloud increase repulsions. That's why it is a less unstable right now. That's why it is a very less stable. Now, yes, time finished. Okay, 1990. Listen, 19. Okay, now. Why does benzene undergoes electrophilic substitution reactions easily and nucleophilic with a difficulty? What is the benzene? Nucleophile or electrophile? What is the benzene? Electrophile or nucleophile? No, only one is Electrophile? Benzene is electrophile. Benzene is nucleophile, having pi electron densities, pi bonds. Pi bonds means what? Nucleophile, na? Right? Nucleophile. And electrophile when electrophile will come, means he will help, right? Now he will donate electron. But when nucleophile will come, that time what happen? Repulsion. So that's why nucleophile is not easy. Electrophile is easy. Understood, everyone? Benzene is nucleophile. Understood? Okay. Next class I will continue.